Alright guys, so welcome to another edition of the Blue Tech Empire main stack tutorials. So we are going to be continuing from where we ended in the last video. We're looking at numbers or primitive types. We have looked at the integer, which we can also call integer literals. We have looked at floating point literals. We looked at boolean. So just like I was telling you guys, we have integer literals. As you can see, integer literals can be a form of a number, like you can have 0, 1, 4. So I'm just going to write console.log. These are different integer literals. You can have 0, you can have 200, you can have, let's say, 1000, and maybe you can have all these as integer literals. So let me see the different ones. Alright, so you can see what we have here. As you can see, we printed a couple of integer literals. Now there's a difference between a literal and a variable. So if we say here is a literal, for example, here is a string literal, we just print it directly in here, hello world. So in here we have a string literal. It's when the variable or the local variable, or let's say the primitive value, is displayed directly. So here we have a string literal hello world, but if we have it like this, if we have let message be equals to hello world, we can now say here we have a string variable. Message is no longer a literal. Here is the literal. Now, if we have message is equals to 2, here if we print it directly here, we can call it an integer literal. 2 is an integer, it's a number literal, integer literal, and here we have message. In this case here, it's an integer variable. So that's the difference between a literal. A literal is when the variable or the value is printed or is used directly without any variable. We call it a literal. So if it's 0, 1, 2, 3, all those are literals. Strings themselves are literal, but if it's assigned to a variable, then we can call it now a string variable. So there are other ways of displaying integers. For example, we can say let int 1 be equals to, if you want to use hexadecimal, use 0x, for example, ff, which we all know is if you're not familiar with this, you don't need to worry. Console.log, we can say int 1. So if you're not familiar with this, you don't need to really worry about it. OXFF, I think this should be 255. Let's see. Yeah, 255, because f is 15. We know about hexadecimal numbers. Let's see, this is 15, or it should be correct. Yeah. So, and we have, a is 10, and all those stuffs. So a is 10, I think. Yeah. So if you know about hexadecimal numbers, you can represent them directly like this. Even though it's represented internally as a normal integer, but you can if you're working with binary or image or binary data, most times you use hexadecimal numbers. So usually people love to do like this. For example, FFAFAACD. Yeah, that's a number, hexadecimal numbers. That sometimes when you're coding where you need to use hexadecimal numbers literally. So here is the number. Internally, it's saved as an integer, but you can express it externally as an hexadecimal number. If you want it to be an octal number, you can start, instead of, if you want it to be capital, for example, you can also use something like FFAA, and you have no problem. It's still the same stuff. So you can also, if you want it to be, let's say you want to have a let's say octal number. In that case, we know about octal number, the maximum digit there is 8. You have O followed by O, that's 0 followed by O, then you have your 3, for example, 347. It's represented internally as an integer, but you have it as an octal. Remember, octals, the maximum number is 7, just like how for binary the maximum number is 1, and for decimal the maximum number is 9. So yeah, octal, you can have a group of numbers, then it cannot be up to 8, between 0 and 7. So these are octal numbers. So now in the case if you want it to be binary, for example 1 and zeros, you use what we call 0b, and you can now have binary numbers. So 0b, for example, we know 0b and 0101, or let's say 0101. We know in binary notation that should be 5 or 10. Here you have 5. So You can add as many as you want, 0, 0, 0, 1, all those stuff, and you have everything as you want. So this is not really necessary except for those who really know what they are doing, who want to work, for example, electronic students and students who work with binary and machine languages. They can also, when you work with binary data directly, you may want to do some of this. But in JavaScript programming with browser coding, you may not really need to work with binary numbers directly. So you can have, I told you, OX is for hexadecimal, OO is for octal, and we have OB for binary numbers. So you can use any of that. Those are different ways to represent integers, but internally they are saved as, they are stored as integer. That's why you see when you print it out, it prints by an integer. Yeah, for example, 321, it does not print out how OB, it does not print it out in binary form. So I just wanted you to understand that. So we talked about floating point numbers. For example, let's say float 1. Remember, this float 1 can be anything. I just use float 1 so that you know 3.4. This is a floating point literal because it has a decimal point. So we can print this out normally. Well, we have a problem here. All right, so here we need to write float 1. Float 1. All right, so 3.6. There are other ways of displaying floating numbers. If you don't want to display it like that, you can display it in the form of, for example, let's say, you can also say, let me say 0.45. You must not put 0.45. It's also good. It's also valid in programming. Like 0.45, it's represented as 0.45, but you can say 0.45 like this. If you want, it's still the same as 0.45. All right, so you can also do something like, for example, if you want to say something raised to the power 10, you can say 6.0 E10. This is 6.0 raised to the power plus 10. You have it as 60, I think, million or 6 billion. You can have minus to the power minus 10. You write E minus 10, and you can write it like this. It can also be a capital letter. You see 6E minus 10. Let's use a smaller digit, maybe E minus 2. So we see how small the value is. 0. You see 0.086. E minus 2 just means go back 2 times. It must not be this. You can also have something like this, which is also, it goes back. See 0.62. Just let's assume the decimal point was not here. The decimal point was here. You see, it's going to arrange itself to, for those who know mathematics, they understand very well what is happening. You see 0.0642. You go to 1, 2, or let's see, e to the 2. Yes, here you have now 6.24. So those who know mathematics know exactly what is happening. So moving from there, we have the next part we can look at. For example, I've told you you can also use a capital letter like this, big E. It's okay. You can use a capital letter if you want. And let's see from there. Here is a floating point number. So you can use capital E or that's uppercase E or lowercase e to represent numbers in exponential notation. So alright, so there's a new feature you can use with some of the latest browsers, but I advise you not to use it because most of your users may not be using the latest browsers. You know, when you design a website, you design it for multiple users, and some users may not be using the latest browsers. You can use an underscore to say, for example, let's say you want to represent 5 billion. Now 5 billion has 9 zeros. It might be too long to write it out. You may like omit a zero. For example, if you said let billion, for example, be equals to 3. You want to write 3 billion, 3, 4, 5, 6, 7, 8, 9. You may actually not be certain about this number because you can't really count, for example. So in this case, you can use underscore to separate literals. They're still the same, but you can just use an underscore to do this. Now it's still like a number. It's 3 billion. And if you take, for example, let mod equals to 4, and you can say let product be equals to 4 times billion. And if you console the log if you console the log billion, you're going to have it let's say 3 billion. So no, let's console the log product, sorry, product. You're going to have All right, 12 billion. So you can just use that for convenience. You can use it for multiple stuff. For example, we can have a byte that is made up of, you say, hexadecimal numbers. We can have a byte. So it's, let my bytes be equals to, let's say we want to separate it into four sections. You can have 0x, and in that point, let's say we have ff, then we have ab. Let me just use capital letter. We have EE, and we have 01. Now in this case, we have separated it into four, that's 8 bytes. 8 bytes into space gaps of 8 bytes. In this case, we can still print this out, and you see my bytes. So in this case, you print this out, you can see we have the number represented in as a number or integer, for example. Now in that case, you can use it for any stuff. For example, you can still use it for bytes. Maybe you have OB, and you want to write a really long piece of byte. You can write 111 0011. This is common. For example, if you want to represent an IP address 1010 and 0001, you see this in groups of 1 byte. That's a nibble, 4 bits. So you can see in this case we can print it out, and we have you see yeah, so that's 623. But you see the representation helps. Without the underscore, we cannot separate it into those. So this is supported by latest browser and in Node.js. When we are using Node.js, you can comfortably use this because Node.js usually has the latest implementation of JavaScript V8 engine. So you can be able to use this on Node.js. But I'll not advise you to use it in, for a web application or so, because you're not sure if the user's browser support this. So you can use this even for decimal points too. For example, let's say 4.2, maybe 3, 4, like something like this. So we can print mods like this, mods, and you see it's going to be joined together. So that's it. So you can see the output here. So I just want to show you can use an underscore to separate really long literals. You know, I told you these are literals. Really long literals, you can separate them into different bits. So that's something which is very important for you to know. Okay, now let's look at some arithmetic with JavaScript. We can say, for example, let a be equals to 30, and we can say let b be equals to 12.5. Now we can carry out simple arithmetic operation. For example, we can say let sum be equals to a times b. Remember, you can even have times c or something times c. You understand? You can do this. Let's add c. So we have let c equals to 0.45 e to the 3, something like that. So that's the floating point number. So let's say we console, or let's use document.writeLine so that you see it clearly. Document.writeLine, so you can see clearly we have some. Okay, now let's print it out to see. All right, so there we have 1674. Now I want us to write a function called print that can help us to print stuff big. Console, let's say console function print. Remember, this is a function called print. So we have it's console document dot write line. Let's let it be print in something. Let it give us we pass it a string str. Let it print a string within an h1 tag, or let's say h3 tag, h3. So let it print it sc plus str plus and the closing tag of the h3. So let's try to use our function now. Instead of writing document.writeLine, we'll just write print and see sum. Alright, so we'll be using this function quite often so we can see clearly. Alright, so we have 1674. Now let's change it to h2 so it'll be bigger for us to see clearly what's happening. Okay, so I think perfect now. Alright, now so we can go on. Now we can say let sum be equals to let's see, let sum be equals to, mm, let's say, let's put up, let put up because that was put up, sorry. So let's okay, so let's sum, this was put up, sorry. So let's say let sum be equals to a plus c. Now if we take sum, let's see what sum will give us. So you see 480. So now we can just, that's, now let's try division. uh, let's see what we get. All right, 0 point. All right, so let's see what we get when we say what have we done, division. We'll do modulus, but let's say division, and the common one is subtraction. So let's say a minus c and see what happens. Okay, so there, negative 420. So now we have, apart from division, we can now have what we have raised to the power. For example, we can say 2 raised to the power 3 is, this is for new JavaScript. That's JavaScript ES 2016. That's when this feature was implemented. So only for browsers, latest browsers from 2016 upward. So even though some browsers implemented it much earlier, so you see 2 to the power 3 is 8. You can write 2 to the power 5, I think it's something like 32. So we have that. So the next arithmetic operation is, you need to know you can use braces. So for example, if you write a plus b plus c divided by, let's say 3. Now you can think this will calculate the average. No, do not calculate the average. For example, let's say if this was 2 plus 2 plus 2 plus 2, 2, 4, 6 divided by 3, you expect it to give us 3. 2, 4, 6 divided by 3, you expect it to give us 2. But let's see what it will give us. Let's print out product, and let's see. Remember, print is a function we declared. The print is a function we declared there. So let's see. All right, it gives us 4.68. Now let's move from there to let's say, instead of doing that, you see it gives us a different number, but you can use bracket. Remember the board mass, because division has a higher precedence than plus, so this will be 2 divided by 3, then 2 plus 2 plus 2 divided by 3. So this will be evaluated first, then 2 plus 2 will be, that's 4, will be added to that. So to make the browser or JavaScript know we want 2 plus 2 plus 2 plus 4, you can use bracket. Remember, from board mass, it starts with bracket. So bracket has a higher precedence. So whatever is in the bracket is going to be executed first. And then here we're going to have the correct answer now. See 2. So what of if we want it to be opposite? We can tell the browser, all right, so you just need to add this 2 plus this 2 here first. Then you can now separate this together, which means 2 divided by 3 will be evaluated on its own. 2 plus 2 will be evaluated then. So it will be 4 divided by 2 divided by 3, which will give us some kind of decimal point something. All right, so you see, you can use bracket to actually separate your mathematics or make your mathematics clearer, or try to explain to the browser exactly how you want it to do the mathematics for you. So I advise you to use bracket most times when you're doing mathematics in JavaScript or in any programming language. It's always good to use brackets. Take note of raised to the power we used here. So let's look at some other functions you can use with the numbers. So the math object, the built-in math object, math, has a couple of functions. Math dot, you can see them. These are constants, e, square roots. For example, let's see math dot pi. Let's print math dot pi. So these are just some constants in the math. Math is a built-in object in JavaScript. You can call it anytime. Math dot e. Let's see math dot e. Yeah, I think it should give us 2.7. So let's print a couple of them. Okay. All right. So so let's see math dot bin 10, math dot. For those who know mathematics, you can use this log 10 to the e. There are a couple of them. You can use any of them. square root, mat dot square root, I don't know, so square root of 2, something like that. So let's look at all these stuff we printed out. So there are a few. Alright, so here are the constants you can see. So apart from constant, we also have functions. For example, we have mat dot power. So we can say print, let's see, mat. Remember, you can assign this to a variable. So let me just print result. So result. You can print our result by creating a variable here. Let result be equals to mat dot power. Mat dot power, we can say 2. The first one is the number and the second one is the power. So 2 raised to the power 5 in this case. So here we have 32. You can also have mat dot round, which is to round a number. So let's say we have let's say 2.6. Let's see what mat dot round will give us. It gave us 3. What if it was 2.3? I think it's going to give us 2. So you can round a number down or up by using the mat dot round. Next we have mat dot cell. Mat is like mat dot ceiling, means move to the ceiling, for example. So mat dot 3 will move to 2.3 will move to, I think, 3. That's the ceiling. So let's say it 2.3 will move to 3. And this one is not rounding down, it just moves upper to the nearest integer. It just moves upward to the nearest integer. So even if you have something like this, it moves upward to the nearest integer. And you can, even if it's 3, will go to 4. Whatever it is, if it's 2.6 or 2.9, it still moves upwards. So this one does not round down or round up. So the next one is floor. Now floor rounds downward. Floor. So ceiling and floor. So no matter what, in this case, we'll still move down to 2. So in this case, it's still going to move down to 2. Let's see. In this case, it's still going to move down to 2. Let's put this here. In this case, it's still going to move down to 2. And whatever the case is, it's always going to move down to 2. So even if it's 2.2, so it moves down. Floor is just like round down to the nearest integer. So it discards the decimal point. Then the other one we have is absolute. Find the absolute value. Absolute just remove the, if you have a value that you think has negative points, if you write up absolute, will actually find the absolute of a value x is this the square root of x squared. So it actually eliminates the decimal point. So for example, in this case we have you see it removes the decimal point. If there's no decimal point, we just have the normal number. So absolute is to remove the decimal point. So there we have the next one we can have is, so next we have the max function. The max will return the maximum of any any number of numbers. That's crazy. 45, 1000, 3, 4. So max returns the maximum of an array of numbers or a group of numbers. So here we have 1, 2, 3, 4, 5, 6, 1, 2. That's 5 numbers. So let's see the maximum. So you can see the maximum is 3,400. Of course, we are sure. While max.min returns the you see the minimum of a couple of numbers. In this case is 30. So if you have a minimum of, you will use this a lot of times. So I just want you to take note of most of this. So we have the mat.min. Next we are going to see mat.random. So mat.random gives you a random number. Now I'm going to show you how this works. So we have mat.random. So mat.random. We are going to look more into this function, but let's see what it gives us. So every time you refresh, you're going to have something new. You can see it gives us a random number. See, now if you want the number to be let's say between let's say you want the number to be, let's say between 3 and 10, or let's say 3 and 10, yes, you can multiply that number by 10. Mat.random times 10, because you see it's 0 point something. So once you multiply by 10, you see you have 0.3, and then you can either use floor or CL. any or round if you want. So I can say math.random. I can now say math.round. Let's say math.round round. Then I can say now math.random times 10. So in this case now I'm rounding whatever I got to, so you see every time I'm getting a random number. So that you can use any of those tricks. If I multiply by 100, I'm going to be between you see, so, and if I multiply by 1000, I'm going to get between this. So you see, so you can manipulate it as you like to particular limit. So if I want it to be for example, if I want it to be between 1000 and maybe 2000, there's stuff I can do. You understand? I can do some mathematical manipulation, but for that we aren't going to look at that because I'm just showing you the different functions under the math object. So we already saw some constants up. Showed you math.py, math.stuffs, and all those math dot. So for example, if you let's even see math.py. I think we printed that out already. Let's see 3.14 something something. Yeah, so that's math.py. You have a couple of functions as you can see. You can see them all here. These are the different functions, and these are other math. These are methods. These are constants. You see they have a different kind of cubic box, while these ones have a square box. So these ones here are all constants, while these ones here are methods or functions of the math object. So we'll continue with some of the method, but you can also see, let's say this is math.e. For those who know mathematics, they know the e constant and its use and its meaning. But let's say next, let's see math.square roots of. You can now find the square root, for example, of 4. I think it's 2. Let's even find 91, which is I think 8 or something. 2 times 9 is. Let's see square root of math.square root of 81. I just forgot, it's, oh yeah, 9. Math.square root of 25 should give us 5. So for those who are versed in mathematics, they know exactly what's happening. So power, we have looked at power, we have looked at power. Alright, but there's something we need to say about power. For example, if you want to look for the square root, you can still say math.power. The square root of 2 can be 2 to the half. Let's say, for example, the square root of 4 is 2. So let's check 2 to the half and see what to give us. That's 2 to the power half. For those who know mathematics, they know the cube root can be 2 to the 1. 2, like the cube root of 8 is 2. Together, we can say 2 to the 1/3, and we have that 2. So we have 3, for example, the cube root of 9 or stuff. So you can find the cube root of by using this to the power half to the power 1/3. The fourth root of, for example, 8 will be this. So you can do any of this if you want to find the roots. So just know that it's possible to using the math.power function. And now we can go to trigonometry. We have sine, there's sine 60. For example, we can see sine 60. I don't know, it's -3. What of sine 90? Sine 90. I've forgotten those special signs. What of let's see. So what of sine 30? Sine 30. Okay, what of, so we can have what sine 0? Let me see what sine 0 is. Sorry. Sine 0 is 0. So you can use sine, you can use cos, and all those stuffs. So let's see cos 0. I think cos 0 should be 90 or something. Okay, cos 0 is 1, while sine 0. Alright, so we have different stuff, sine, cos. If you want to look at the different types, you know that we have different trigonometry. We have tan. If you want to use tan, you can use math.tan. I think we have tan 90. I don't know whether it's infinity or something like that. Alright, so that's what we get. So for math, you have all those arc-cos and arc-tan and all those triggers. You see a cos, a cosh, a sine, all those stuffs are here. So you can, for those who want to do some mathematics with JavaScript, your free. So we also have even log. For example, we have log 100. But know that when you're using log like this, you're talking of log 10. So log 10 100 is 2, or log let's see, log 2, log 10 2, let's see, it should be 100, something like that. I don't know. Okay, well, I've forgotten. So here is log 10, this is log 2, and we have we can use any log. For example, let's see, log 100, log 100. Okay, all right. So let's see, uh, all over math dot lin 10. I think it should give us what we want. All right, yes. So you can, if you want to get it. So let's see, 2, 2. So this is just for mathematics. I just want to show you it's possible to do some stuff here with mathematics. So let's say, let me see this, and let me see how it goes. So you can do all these stuff. All right. So you can do all these stuff for those who takes, you can feel free. So let's see, you can even use exponents. So math dot exponent. Let's see, x exponent exponent to the of 3. So you can use exponents and you can do all those stuff. So you can do whatever you want. So that's e cubed. You know, e to the power, this exponent is e to the power. This one is e to the power 10. That's constant e to the power 10. So you can do that, and whatever you want to do. So we have a lot of functions, but there are some new functions that were only added to year 6, that's 2015 of JavaScript 2015. And those ones, we have the hypotenuse of something. So, for example, the square root of the sum of squares of all arguments. You can see the hypotenuse of 3 and 4. You have the hypotenuse, you can have 3 4 3 4. Let's see what will give us. So 5, you understand. So we have all those hypotenuse. Let's see, 5 12. So we have this 13. So you can find the hypotenuse, and you can find log 10. You can find the cube root, and you can find all those terms. For example, the cube root of 27, we know that we can say cube root of 27, or is, for this is just for those of who know mathematics. You can see we have 3. So we can have cube root, we can find the log 10 of something, we can find log 2, and all those stuff. So the last thing we'll see here is to remove. If you have a floating point number and you want to remove the floating point, for example, let's say b, you want to just discard the floating point, not rounding up, not rounding down, we can use truncate. So truncate b will return at, you should just return 12. It just ignores the decimal point directly. So it doesn't round up, round down, or whatsoever. It just ignores it. So even if we had 9 here, it's just going to discard the decimal point. So here we have 12. So it doesn't know about rounding up or rounding down. So there is what I wanted to show you. All right, now let's move ahead. In JavaScript, you know, we have, in normal numeric stuff, we have negative infinity, we have positive infinity. For those who know mathematics, you can generate infinity in any way. For example, the square root of 1, the square root of negative 1, for example. Let's see what will give us. Math dot square root. Let's see the square root of negative 16 of, you know, the square root of a negative number normally is not possible in mathematics. So we have, it's not a number in that case, it's not an infinity number. But let's say if we have, let's say something like 1 divided by 0, this should give us infinity. So we have here we have infinity. But if we have something like negative 1 divided by 0 in mathematics, so you should know we have negative infinity. So you should know in JavaScript we have what we call infinity. Infinity like this. It's like it's a keyword to represent infinity, and we also have negative infinity. And know that infinity times Any operation with infinity also gives you infinity. So it's just, you should know that. So for example, if you want to, there are some times where you want to calculate the largest number and you want to start from a big number, you can give that big number infinity, then you start changing it, or you give the smallest number negative infinity. We'll come to that later on. So we have positive and negative infinity. And so you can see division by 0 in Java is not an error. It gives you infinity, either negative or positive infinity. And you can see we also have not a number. If something, if we have stuff like not a number, like you saw the example where I tried to find the square root, mat dot square root of a negative number. You saw it gave me not a number. Um, we have that. We also have yeah, we if you try to also do like stuff like infinity infinity all over infinity, you have also not a number. And not a number, if you also try to like add, multiply, let's say you try to divide a string, maybe hello, you try to divide a string by 2, string divided by 3, it's not possible, because so in JavaScript an error will not be generated where you have not a number to, you understand. So those are some stuff that you need to divide a number by a number. You cannot divide a string by a number. In this case now you can have one. So um, those are cases where you can have not a number. So to represent infinity, you can also use the numbers object number dot. You can have positive infinity. That's result result should be equals to, let's try to, you have number dot positive. Let's print out result and see. So infinity, and we have, you can see the largest positive number is number dot positive infinity, and the largest negative number can be number dot negative infinity. So you can do that to result in negative infinity. So you can do that if you want to put a default largest, smallest, smallest number, or a default biggest number. You can do all that. So all right, so this video is mostly about numbers. In the next video, I'm going to continue. We are going to round up with JavaScript numbers, and from there, we are going to move to JavaScript text. So see you in the next video, and have a nice time. Thank you.